Hello everyone, myself Shrivardhan Raviskar and this is SSJB's Mentora. We are going to start this video with the discussion of Unit 1 of the Digital Signal Processing. In previous video, we have already discussed that under the syllabus of DSP, in which unit, which topics we are going to cover. So today we are starting with the Unit 1, which is the signals and system. So let's analyze what are the exact signals and system looks like. Signal is kind of something which carries some kind of information, which is having some dependent and independent variables. I am talking about signal which is based on the audio signal or the video signals. In day-to-day life, mostly we talk about the various signals like the sinusoidal signal might be there, the EEG, ECG signals are there. Not that choke wala signal, but these are the professional daily use signal, the audio signal. Most of the times we utter about that lower frequency or low decibel audio. What are those? Those are the signals. Okay. So in the signal, what properties are there? So what is the basic information, basic definition of signal is like, look this. A signal is a physical quantity which is having some dependent and independent variables and carries some kind of information. It might be having some relatable information which is useful for the one end to another end, and the system is a kind of structure which process these signals. Okay, signal and system both are the different terms. If I am having any signal, let's say I am having any signal, it's given input to a box. Let's say that black box, that black box is a system. This is the system, and for what purpose the system is used to get the desired output, for what functioning, for what purpose we are going to use that signal. Okay, for that the system block is there. So signal and system, signal carries some information and system processes that information. Okay, now let's analyze which are the some very basic description of the signals. Signals at the very base level classified into three types: the 1D, 2D and the 3D. Now 1D is kind of signal which is the 1D signal means having the only one dependent variable. Okay, so only one dependent variable, only one dependent variable, only one independent variable it will be having. Okay, so if I am having any sinusoidal signal, for this signal, the t, the time will be the independent. It will don't it will not depend on any other property. It will be increasing like 0, 1, 2, 3. It will go on increasing. And let's say this is the x of t will be function of, let's say it's a sine signal. So sine t, it will depend on t. So one dependent and one independent. Earlier I have said that one means one dependent also, but the necessity is that it should have the one independent signal. Okay, so and this sinusoidal signal is using the two variables only. Okay, so it will be having one independent and one dependent variable. Then next comes the 2D. 1D signal also contains some ECG, then EEG kind of signals. These are the 1D signals. Then 2D is the two-dimensional, or we can say it will be having the two independent. Here, the independent word is important because it must be having two independent variables. Other might be dependent or independent, but minimum two is important. So, two independent variables, independent variables are must. The best example of 2D signals is the image. I hope it's visible. If I am having image, it is having the pixels, x and y pixels, the x pixels and in the y axis. Both are independent in nature. X and y direction having independent pixels will be there. So they will not depend on each other, or x or y will not control each other. So two independent pixels will be there. So image is the example of 2D signals. And third comes the 3D. Obviously the 3D signals. And the best example of 3D is the video, because video is the collection of images arranged in specific sequence creates video. So video will be having the three independent, here also independent word is important, three independent variables which will create video. Video is kind of frames, frames arranged in specific manner. Okay, so collection of this will create the video. So this is the basic description of the signals, the 1D, 2D and 3D. And further part is based on these specifications only. And also we have analyzed the system. Let's say I am having any signal, signal is given input. System will analyze it and will create a specific desired output. Various systems are there. The LTI system, which we will study further. The LTI system, I will just give the introduction to it. LTI, it's a linear time invariant system, because system is having multiple types. Linear, non-linear systems are there. Time variant and invariant systems are there. Along with signals are also various types. The power signal will be there. The energy signal will be there. We will also see some basic fundamental signals after this. Okay, so we have just analyzed the working of the system. We will see the system and its types further. But before that, let's see some basic elementary signals, which are must to start any kind of study in the DSP. So let's start with the unit impulse function or the delta function. Delta function is a kind of spike. Okay, I will just draw it, then you can learn it easily. Just a spike is there at the zeroth index. Okay, so this is the delta function. Delta function is a kind of spike, and its mathematical equation looks like this. This is the complete graph. This is the time axis, and this is the delta t. Delta t is having value 1 at t is equals to 0. This is the necessity of this delta function, that delta t, the value of that function must be 1 at t is equals to 0, and it will be 0 elsewhere. Means for any value for any value of t except 0, that delta t will be 0, and for t is equals to 0, delta t will be 1. Okay, now the next signal or the function, we can say the unit step function. What is that? Unit step function looks like this. It will be having a constant value. Okay, it is represented by u of t, and this is the time axis. This is the zeroth index, and we can write, I hope it's visible, and we can write its equation as u of t is equals to 1 for t greater than or equal to 0 and is 0 elsewhere. Elsewhere means t less than 0, the u of t will be 0, and for the t greater than or equal to 0, that value of u of t will be 1. This is the unit step function. Okay, so first of all we have seen the delta function, then second we have seen the unit step function. Now let's go to the third one, the ramp function. Now the name itself suggests that the ramp function, which is having this kind of y is equals to mx plus c kind of ramp, and this is the slope of that ramp. This is the slope. This is the t axis. This is the r of t, the ramp function. And the speciality of ramp function is like, see, the 0, 1, 2. As the t is increasing, the ramp is also increasing. So you can guess that the sorry the equation of ramp function r of t will be equal to t, not 0, not 1. It will be equal to t for t greater than or equal to 0. Means if t is 1, r of t will be 1. If t is 2, r of t will be 2. And it will be 0 elsewhere, similar to other cases. So this is the equation of ramp function. And at the end, we have the sinc function. Sinc function is a kind of, you can say, the sinusoidal, but it goes on decaying. it goes on decaying at the both the sides, like kind of damping function is there. Okay, and the sink function, its equation is given by sine c of t. Sink t is equals to sine of t by t. Also, we can write the normalized form of the equation equal to sine of pi t upon pi t. So this is the equation for the sink function, and this is the equation for the unit ramp function. Also, one thing we want to add that the area under the curve in the delta function is always 1. I will also write here the area under the curve, area under curve is equals to 1 for the delta function. So in this video, we have seen the basic definition between the signal and system, the basic some elementary signals we have analyzed. From the next, in the next lecture, we will see what are the systems and their types. Thank you.